Hey guys, welcome back to one more video on the channel. And I have recently uploaded this particular video on my YouTube channel, and it has done wonderfully good. Judging by the statistics of my small YouTube channel, it has gotten 6K views. And here I have demonstrated a really cool approach to solve this algebra problem using trigonometry, and it has done really well. I got a lot of appreciation through the comments, and I thank you for that. What we are going to do in this particular video is to solve this same question using a JEE relevant concept. What is the concept? You know King's rule for integration. Alright, we are going to apply the same King's rule to solve this particular problem. So, what is King's rule? So, King's rule is something. Also, if you're thinking to skip this particular video at this point in time because you already know the solution, do think otherwise because this is going to add a lot of value to your preparation. So this is your King's rule. Alright. Now what I'm going to tell you is that this King's rule can be applied even to the summations, not just integrals. Alright. Um, and why is this? Have you ever given a thought about this? What is an integral? So if you have a curve, you have to calculate the area under this curve. What is the integral? Integral is nothing but the sum of areas of all these rectangles, isn't it? So the summation is nothing but an integral when this width of the rectangle tends to 0. Alright, the summation is essentially getting converted into an integral when the width of the interval is 0. So that's what is an integral. So the properties, most of the properties that holds good for integrals holds good even for the summations. Now in case of, what is the King's rule in case of this? So let us say you have a function f of x dx. So this will be same as n is equals to 1 to 99, your a plus b in this case. So let us denote it with a and b to be generic. So this is your a and that upper limit is your b. Alright, so this is a. So this will be simply a plus b minus x dx. Alright, so this is what it is. Now let us see how this King's rule can be applied to this particular problem. So let us say we have to find out the value of this. Let us say this is x. So we have to find the value of n is equals to 1 to 99 square root of that will be 10. Is it 10? I think it's okay, 10. So 10 plus root n upon square root of n is equals to 1 to 99 square root of 10 minus root n. Now, according to the King's rule, you can replace n with 1 plus 99 minus n, and the value of x will not change. So you can replace n with 100 minus n. So let's do that. So n is equals to 1 to 99 square root of 10 plus root over 100 minus n upon n runs from 1 to 99 upon square root of 10 minus root over 100 minus n. Now let us see what this term inside the square root is. 10 plus 100 minus n. Alright, this is simply 10 plus root of 10 plus n multiplied by root of 10 minus n, isn't it? Hmm. Sorry, this is 10 plus root n. This is simply, this is 10 plus root n multiplied by 10 minus root n. So I just wrote this 100 minus n as 10 plus root n multiplied by 10 minus root n. This is what we have done here. Alright, now uh, now one more thing that we are going to do is that, let us say you multiply this with 2 on both sides. Then you have 20 plus 20 plus 2 times root of 10 plus root n multiplied by 10 minus root n. So this 20 can be written as root of 10 plus root n whole square plus root of 10 minus root n whole square. If you expand this, you will get 10 plus root n and if you expand this, you'll get 10 minus root 10. Eventually this and this will get cancelled, and your 10 plus 10 will give you 20. All right, so that 20 can be written like this: plus 2 times of root of 10 plus root 10 multiplied by root of 10 minus root 10. If you consider this as a and this as b, it looks something like a square plus b square plus 2ab. So it is simply is equals to a plus b whole square, 10 minus root 10 whole square. Now what is this? This is 2 times of this particular quantity. So 2 times of this internal quantity. So similarly, 2 times of this internal quantity can be written as 2 times of 100, oh sorry, 10 minus root of 100 minus n can be. So you can follow the similar process, then you will get it something like a minus b whole square. So this is simply 10 plus root n minus square root of 10 minus root n whole square. So now let us substitute those things into these expressions. All right. So x is equals to integral, sorry, summation n is equals to 1 to 99. Okay. So square root of this can be written as, so you have to take the square root of this on both sides. So that is, so when you take square root here, you have root 2 times this quantity. This is this quantity, root 2 times of that quantity is equals to, when you take square root here, square and root will get cancelled. So in the numerator, we will simply get root of 10 plus root 10 plus root of 10 minus root 10 divided by this root 2. All right, divided by root 2. Similarly, in the denominator, we get n is equals to 1 to 99 square root of 10 plus root n minus square root of 10 minus root n divided by root 2. This root 2, this root 2 will get cancelled. So now all we have is, in the numerator, we have n is equals to 1 to 99 root of 10 plus root n plus root of 10 minus root n upon summation n is equals to 1 to 99 square root of 10 plus root n minus square root of 10 minus root n. This is your x. Also here, this is also x. Let us write them side by side. So x is also is equals to sigma n is equal to 1 to 99 square root of 10 plus root n upon sigma n is equals to 1 to 99 square root of 10 minus root n. So this is the original question asked, and when we applied, we got something like this. Correct? Now let us say this quantity is p and the denominator quantity is q. Now here you have x is equals to, so this is your p, all right, plus this is your q divided by p minus q. You have this thing. All right. Now x is equals to, divide the numerator and denominator with q, then you will get p by q plus 1 upon p by q minus 1. So this gives us x is equals to, we know p by q is x plus 1 upon x minus 1, and we have to find out the value of x. All right, so just cross multiply this, then you will get x square minus x is equals to x plus 1. So x square minus 2x minus 1 is equals to 0. So this is simply a quadratic equation. See how beautiful it is. So you have a sum, you have a quantity for which you have to find out the value. You use the King's rule, and then you got this particular result. So you denoted this as p by q and converted it into a quadratic equation, and the root of this quadratic equation will be your answer. All right. So let's find out the roots. Minus b plus or minus square root of b square minus 4ac by 2a. So this is simply 2 plus or minus root 8 upon 2. This is simply 2 plus or minus 2 root 2 by 2. This is simply 1 plus or minus root 2. So now if you check, x is equals to 1 plus root 2 is a positive quantity, x is equals to 1 minus root 2 is a negative quantity. Now, if you carefully observe, This is under square root. So this term, every term in the numerator is positive, and every term in the denominator is positive. So therefore, there is no way that you're going to get a negative value as an answer. So therefore, this is ruled out. So x is equals to 1 plus root 2 is your answer. And that's it. We are done with the problem. So now what should be your learning from this video? The learning is that the rules which are applicable in integrations are also applicable in summations, maybe with some modifications, but they are applicable. But because essentially integral is just a summation when the width of your interval is 0. I hope you have got something to learn from this video. Also, in the past video, in this particular video, people are commenting that this problem can be solved using component and dividendo. Yes, I agree, and that is a conventional, traditional way of solving this particular question. And I thought most of you might be knowing that particular method to solve this question. Hence, I did not present it. And there are other methods as well. All right. So this is such a beautiful and classic question, which has lot of ways to solve it. That's all for this video. I'll meet you in the next video. Till then, take care. And do not forget to give it a like if this video added some value to your preparation. Like the video. Share it with your friends and subscribe the channel for more such content. And you can check out other videos on the channel. There are a lot of fantastic videos on the channel.